This lesson is on ellipses. What is an ellipse? The definition that we will use for an ellipse is that the sum of distances from two fixed points is constant. So an ellipse is the set of all points, so every single point that exists, where the sum of the distances from two fixed points is constant. We call these fixed points focus points, or foci or foci. So that is what an ellipse is. And so, for example, if we have 2 points, 2 focus points, the sum of the combined distances between those 2 points and every point on the ellipse is the same. So, for example, let's say that sum is 5. If this distance is 1, then this distance must be 4. So 4 plus 1 is 5. And everywhere we go along the ellipse, that's going to work out. So if we look at this particular situation, let's say that distance is 2, then this distance must be 3. So that's basically what an ellipse is. It's where we take the sum of the two distances from these fixed points called focus points, and they have to be constant. So whatever that distance is, it is always the same. And I just picked 5 for example, but it could have been anything. So here is another example of what that looks like on video. You can actually create an ellipse by taking pins or just sticking your finger on a piece of paper and putting string behind those pins, or having some string behind your finger. I don't know why it isn't doing what I wanted. So and my voice just changed all of a sudden. But that is, oops, that's what an ellipse is. So that's our definition of an ellipse. The equation of an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So let's talk about what each of these parts means. Obviously, we should notice the center is very similar to what it was in a circle. So the center is h comma k, and you'll see why I have two different forms of this in a second. So we can actually have an ellipse that goes in two separate ways. There are two things that we will see from an ellipse. One type of ellipse looks like that, and the other type of ellipse looks like that. So those are the two major types of ellipses that we will see. One looks longer in the x direction and one looks longer in the y direction. So if we take a look at what everything is, the center is obviously the point HK. The x radius is the length from the center to the edge in either direction. Okay, so the x radius is going to be just this length here. That is defined to be a. So if we look at the x radius is a. Now the major axis is the length of the longer axis, or from one edge to the other. So in this particular problem, the major axis is 2a. Likewise, the y radius is b. So from the center to the edge of the ellipse in the shorter distance, that's the y radius in this particular case, so that's b. The definition of what a minor axis is the entire length of the shorter axis, so that's the minor axis, and in this case, that's 2b, okay? So if we look at this particular case where uh, the ellipse is stretched in the other direction, h case remains the same. Our x radius is still a. So notice that a squared and b squared show up underneath this x minus h and this y minus k. So if we have an example, as we'll see in problems later, for example, if this a squared term is 16, then a would be 4. And so our length from the center to the edge in this particular case would be 4. So our x radius is still a. Our major axis is no longer 2a. That is now our minor axis in this problem. Our y radius is b, and our major axis is 2b. So that should be relatively simple for us to understand. Now, the foci are those fixed points where if we took that string like we just saw on the video and moved it around, we would end up getting the ellipse. Okay, and the length of that string dictates how big the ellipse is, obviously. So if we're looking for the focus points in an ellipse that is stretched out in the x direction, the focus points are on the major axis, which would be the x. There would be a focus point on each x radius. The focus points have a distance of c, so we call this the focal length. And so that distance is c, and we find c from the formula c squared equals the major radius squared minus the minor radius squared, or the semi-major axis squared minus the semi-minor axis squared. So in this case, it would be a squared minus b squared. And if we're looking at this as c, we find it from c squared equals b squared minus a squared. So our focus points in this particular problem, where it's stretched in the x direction, would be, remember our distance is c, it would be h plus or minus c, comma k, because they're in the x direction. And over here where it's stretched in the y direction, it would be h, comma, k plus or minus c. So remember, c is our focal length, and c squared equals a squared minus b squared is something that shows up. One thing that I want to make a point of noting is, let's say we have an ellipse, and the center is at hk, and then we know this distance is c. We know that this distance was b since it's stretched in the x direction. That's a. So one thing that we have to be aware of is that the Pythagorean theorem holds in ellipses, so that whatever the major or the semi-major axis is, or the longer radius, that is actually equivalent to the distance from the focus to what we call the covertex. So so there are two vertices. There are two vertices on an ellipse. They are in the longer direction. There are two covertices also on an ellipse. Those are in the smaller direction. And so the distance from the center to the vertex is also equivalent to the distance from the covertex to the focus. That's actually a pretty incredible thing. So if we were looking at the one where it's stretched in the y direction, this distance from C, or from this point, the focus, to this point, the covertex, the distance from the focus to the covertex is the same as the distance from the center to the vertex. And notice that the vertex in this problem is going to be in the y direction because it's stretched oblong in the y direction. Okay, time to do some problems. Graph x plus 1 squared over 9 plus y squared over 25 equals 1. And then we'll deal with all the other things that go along with it. So the center is at negative 1, 0, because h comma k is negative 1, 0. Notice that a is 3 and b is 5. So that means this is going to be stretched in the y direction. That means that for the y, we're going to go up and down 5 from the center. And in the x direction, we're going to go to the left and to the right 3 from the center. So that's kind of what our graph looks like. If we wanted to find vertex points, they would be at negative 1, 5 and negative 1, negative 5. If we wanted to find covertex points, the covertices would be at 2, 0 and negative 4, 0. The major axis has length 10. The minor axis has length 6, because 5 times 2 is 10 and 5 times 3 is 6. The x radius is 3 and the y radius is 5. And then the focus points, those are the other things that we really have to care about. The focus points, remember, if we look at where the focus is going to be somewhere around here. This distance, which is c in our definition, and this distance, which is a in our definition, will make the Pythagorean theorem with b. And remember that b is equivalent to the length of the major axis. So miraculously, that ends up working out. So since b was 5, 5 squared is going to equal, I'm sorry. So in this particular case, we have c squared equals 5 squared minus 3 squared. Now, if you wanted to, you could make this just a Pythagorean theorem problem, so you don't have to memorize anything. And in this case, that's 3 squared plus c squared equals 5 squared. Obviously, you could get that by just adding the 3 squared over, but we should know from our triples that c equals 4. So the focal distance is 4. And when we are looking at how long that's going to go, we take the center, negative 1. The x value is not going to change. We're going to take that 0 and add 4. So we have negative 1, 4, and negative 1, negative 4 are our two focus points. Next, graph the following. I'm going to do the completing the square relatively quickly. I'm going to take the x terms and factor out a 16. I'm going to take the y terms and factor out a 4. And then we have negative 36 plus the two things we're adding on the other side. When I complete the square, negative 2 divided by 2 is negative 1. And negative 1 squared is 1. So that means I'm adding 16 to the left because remember I'm taking 1 times 16. So I'm going to add 16 to the right. Y plus 3, because 6 divided by 2 is 3. 3 squared is 9. I'm adding 36 to this problem here because 4 times 9 is 36. So this all equals 16. In order to get it to look like the form that I had originally, remember where everything equals 1, I'm going to divide by 16. So this should end up working out pretty well. I'm going to divide everything by 16. X minus 1 squared divided by 1 plus y plus 3 squared divided by 4 equals 1. So if we graph this, we're going to have another ellipse that is oblong in the y direction. The center is at 1, negative 3. The vertices are going to be plus and minus 2 in the y direction. And then our covertices are going to be plus and minus 1 in the x direction. So it should be pretty easy to figure out where the vertices and covertices are. Remember that the vertices are in the x direction in this problem and the covertices are in the y direction. Now the foci, let's figure that out. So um, what we're looking at here is I'm going to make a Pythagorean theorem triangle. This is the focal length. I'm just kind of blowing it up a little bit since this is a pretty small ellipse. This is the focal length. This right here is the semi-minor axis, and the minor axis is 1, or the minor axis is 2, so the semi-minor axis is 1. That's the same as the x radius in this problem. And then the semi-major axis is 2 because 4 is 2 squared. So I have to do the Pythagorean theorem in this problem, and I end up with c equaling the square root of 3. Notice that's also the square root of 4 minus 1. So if you take the bigger number in the denominator and subtract it from the smaller number in the denominator and take the square root, you end up getting the proper answer. So our foci are going to be at 1, comma, negative 3 plus or minus the square root of 3. And so that puts us a little bit short of where the vertices are. Okay, finally, write the equation of the ellipse with vertices at 5, negative 4, and 5, 6, and focus at 5, negative 3. So our major objective now is to figure out how far in the y direction we go. I'm just going to make an ellipse. I don't really know if that's exactly how far we're going in the y direction, but it'll at least give us a start. So the first thing we have to do is figure out where the center is. The center is going to be directly in between those two vertices. So if you take the average of negative 4 and 6, because those are the things that are changing, you end up getting 1. So our center is at 5, 1, which means that we have x minus 5 squared plus y minus 1 squared divided by a couple numbers equals 1. Our job is to figure out what those numbers are. It's pretty easy to figure out what b is going to be because it looks like the b is changing, and if those are the vertices, that means that's the longer part. If the center is at 5, 1, and we go all the way up to 5, 6, that means that that's 5. So our semi-major axis is 5, which means we're going to put 25 under the y minus 1. Now, in order to figure out what goes underneath the x minus 5, we know that our foci are 4 away from the center, And so in order to figure out what's happening, we can draw our Pythagorean right triangle. So this is 5 because that's the semi-major axis. This is 4, the distance from the center to the focus. And so our job is to find B. Well, this is a really nice triangle for us. B ends up, I shouldn't say B because that is this is actually the x direction. So our job is to find A. And in this case, A equals 3. So that means we put a 9 underneath there. Um, and I think that's all that I had to do in this case. Yeah, it is. So hopefully you learned something and have a good day.